System of rice intensification. Module 5. Research experiences of SRI across the country. At the end of this module, we will understand response of SRI method on grain yield across the locations, varietal response to SRI, nursery area and seed saving and saving in water, root and shoot dry mass, nutrient use efficiency and status of soil available nutrients, influence of SRI on microbial development and influence of SRI on incidence of insect pests, reduction of the duration of the crop, and socio-economic studies and frontline demonstrations. Lesson 1. Response of SRI method on grain yield across the locations. The results of MLT clearly indicated that the performance of SRI varied from location to location, indicating that response of SRI is location specific. SRI recorded higher yield than ICM and ST at half of the locations, that is 10 to 12. SRI and ICM were comparable in 5-6 locations and found promising over ST. The mean yield advantage of SRI over ST ranged from 7 to 20% irrespective of soil and locations across the years. Figure 14 RI performed consistently superior across 4 years. Table 6. This increase in grain yield under SRI could be attributed to profuse tillering, improved soil aeration achieved through the soil disturbance by cono-weeder operation, in addition to effective weed suppression. Tyagarajan et al., 2002 and 2005. Table 6. Performance of SRI in different locations across India. Lesson 2. Varietal response to SRI, nursery area and seed saving and saving in water. Varietal response to SRI. Contrary to the perception that SRI method is genotype neutral, significant differences were observed between the varieties under SRI. In general, it was observed that hybrids, 4 to 42% yield advantage, performed better over the varieties, 2 to 17% under SRI as against ST. The hybrids KRH2, HR1, 1 to 6, and PHB 71 and DRRH2 performed better as compared to the varieties. Since seed requirement is quite low in SRI, this could be the best method for cultivating hybrids, whose seed cost is relatively higher compared to inbreds. Most of the varieties generally performed better, but there are reports that some varieties perform much better than others. Therefore, to identify the response of different genotypes to SRI practice at different locations, locally popular varieties of different duration were tested at 16 locations. Results indicated that there was a significant differential response of genotypes to SRI method of cultivation. Based on the mean over the locations and among the group of cultivars, the performance of late and medium duration varieties and hybrids was found to be better as compared to early duration varieties at most of the locations. It is imperative that, under SRI method, due to wider spacing, those varieties which have high tillering ability perform better as compared to the shy tillering ones. Nursery area and seed saving. As a result of adopting wider spacing and planting of a single seedling or hill at a spacing of 25 by 25 centimeters, there would be only 16 hills per square meter, as against 44 per square meter or more in the conventional method. Sufficient nursery required for 1 hectare under SRI could be raised using just 5 kg seed, as against 20 to 30 kg per hectare under ST. In case of hybrids, 66% seed cost could be saved by adopting SRI method. The significant seed saving will promote seed multiplication rate, purity of seed, single seedling planting, in faster availability or spread of released varieties. Further, the nursery area for SRI method is just 100 square meter per hectare, which is 1/10 of area required for ST. There will be reduction in the cost of nursery preparation, labor saving, and of inputs for nursery, mainly water, which is scarce during the period of nursery raising in both the seasons. Lesson 3. Root and shoot dry mass. Of the three cultivation methods, ST, SRI, and SRI method with organic inputs, Eco-SRI, the plots of SRI rice had highest shoot mass, mean of all three cultivars, root mass, and root length density. For the root length density, DRRH2 had biggest density with SRI and lowest in control, while Shanti had highest values in ST and lowest in Eco-SRI, Table 8. Similar results are reported by Barrison, 2002. The root system was much larger in SRI, and root pulling resistance, RPR, per clump was more than double for SRI plants. Since SRI clumps are single plants and ST grown rice is transplanted with 3 or more seedlings per hill, per plant resistance is at least 6 times greater in SRI. Table 8. Water productivity as influenced by conventional versus SRI method. Mean of Kharif and Rabi. Shoot and root oven dry weight, gram per cubic meter. Root length density, meter per cubic meter, in top 30 cm soil profile at vegetative growth stage. Lesson 4. Nutrient use efficiency and status of soil available nutrients. The study conducted at DRR Farm, Ramchandrapuram, on sandy clay loam soil with 3 varieties and 3 systems of crop establishment. SRI, Eco-SRI, nutrients supplied through organics, and ST indicated that SRI and ST were on par and significantly superior to Eco-SRI with respect to nitrogen, potassium, and phosphorus uptake in both the Kharif and Rabi seasons. Though the nutrients uptake remained the same, nutrient use efficiency was marginally higher in SRI by 8, and 12% for nitrogen, phosphorus, and potassium respectively during Kharif and 5% for nitrogen during Rabi, compared to ST, figure 5. The amount of accumulation of nutrients that leads to more vigorous plant growth and higher yields is due to changes in capacities of the plant itself, particularly its root system. Barrison, 2002, found considerably higher concentration of nitrogen, phosphorus, and potassium in the foliage at late stage, reflecting better uptake of nutrients at later stages in SRI method. Soil analysis data indicated similar available nutrient status in SRI and ST after 2 seasons of experimentation. Thus, SRI resulted in higher productivity during Kharif, similar nutrient uptake and marginally higher nutrient use efficiency without depleting the soil available nutrients compared to standard transplanting after 2 seasons. Table 9. Table 9. Soil properties after 2 seasons as influenced by different crop cultivation methods. Lesson 5. Influence of SRI on microbial development and influence of SRI on incidence of insect pests. Influence of SRI on microbial development. The dehydrogenase activity, a measure of microbial activity in the soil, was estimated at 2 stages of crop growth in sandy clay loam soils, comparing different methods of crop establishment, indicated that the dehydrogenase activity did not differ at sowing, 161 to 172. However, at vegetative growth stages, dehydrogenase activity was significantly higher in SRI over ST as well as Eco-SRI, Table 10. The amount of organics used in eco-SRI is higher, but the aeration provided with cono-weeding might have had a significant effect on improvement of dehydrogenase activity in SRI. Magdoff and Bolden, 1970, reported that BNF activity is greatly increased when aerobic and anaerobic soil horizons are mixed together. SRI water management practices and recommended weeding with a cono weeder would contribute to the juxtaposition of aerobic vis-a-vis saturated soil. Nitrogen-fixing bacteria are prolific at the interface between these two soil conditions. Detailed trials conducted in farmers' fields indicated no clear trend on microbial development. MBC, MBN, and dehydrogenase activity in rainy season mainly attributed to poor water management. However, SRI plots generally had higher 7 to 25%, MBC, MBN, and dehydrogenase activity only in post-rainy season, as water management and controlled irrigation is practiced only during the post-rainy season. Kranti 2005. Table 10. Dehydrogenase activity. Microgram TPF per gram soil per 24 hours at sowing and at vegetative growth in the experiment. Influence of SRI on incidence of insect pests. Field experiments were conducted in dry and wet seasons in 2005 and 2006 at Directorate of Rice Research, Ramchandrapuram Farm. The pest incidence data indicated that yellow stem borer damage was high at all stages of crop growth period, and its damage, dead hearts, was low in Shanti grown under SRI, 7% as compared to ST, 11.4%. At reproductive stage, the damage, white ear heads, was high in SRI, 28.3%, than conventional method, 21.2%. The study through survey, SRI Adopted Village, indicated that SRI had low pest incidence, resulting in lower or no pesticide application. The benefit-cost ratio was higher for SRI method, 1.77 and 1.76, in two villages of Warangal district, Andhra Pradesh, than conventional method. Padmavati et al., 2008. Similar results of low pest incidence in rice grown under SRI due to vigorous and healthy growth of plant coupled with wider spacing has been reported by Gaspanillo, 2002, Ghani, 2004, Ravi et al., 2007. Total abundance and species richness was high in SRI as compared to conventional method. Among various gills, natural enemies were found more in SRI than conventional method of rice cultivation. Lesson 6. Reduction of the duration of the crop and socio-economic studies and frontline demonstrations. Reduction of the duration of the crop. Field experiments conducted for assessing the potential benefit of SRI, especially in terms of reducing the duration of the crop. Three methods of crop establishment, SRI, SRI Eco, and ST, were compared with three promising high-yielding varieties. Two varieties and a hybrid indicated that a mean reduction of days to 50% flowering was 11 days across seasons and varieties, and also maturity of the crop. Further, SRI method recorded higher grain yield in both the seasons, 1.4 tons per hectare, with reduced duration of crop and helped to cultivate succeeding crop timely. Due to reduction in duration and increase in yields, SRI recorded a higher per day productivity to an extent of 9.4 kilograms per hectare per day and a 21.7 kilogram per hectare per day over ST during wet seasons of 2006 and 2007 respectively. Table 11. Similar trend of reduction in growth duration and increase in per day productivity under SRI have also been reported earlier. Ramesh Babu 2007 and Subbarao 2007. This also helps to reduce the water requirement and facilitates to avoid water stress, especially rice grown in tail-end areas. Table 11. Per day productivity of rice as influenced by methods of crop cultivation. Socio-economic studies and frontline demonstrations. Studies during the past 2-3 years have clearly indicated the superiority of SRI as a sustainable method of rice cultivation. Participant farmers could perceive a unique opportunity in SRI for increasing their income through higher productivity while saving on cost of seed, chemicals, water. Experiences with SRI conducted across several types of soils indicated that SRI may not be suitable in saline sodic soils due to less tolerance of rice at early seedling stages in these soil types.